Hi everyone. In today's video, we're going to look into how to set up TPU virtual machines on Google Cloud. So let's get started. Google has a research support program. It's called TPU Research Cloud. And if you apply using this form here, you will get an email from them. Actually, I got this email when my quota was about to end. But anyway, these are the type of machines that you are allowed to operate as part of the program. So if you operate these type of machines, you will not be charged and it will be included in the research support. I will go through these instructions at this markdown file. It has all the commands that I'll be using right now. I'll make sure that I will link this markdown file in the description below. This is the Google Cloud interface, and these are the products. This is the APIs that you need to enable the TPU Cloud API as a requirement to be included in this research support. And this is the compute engine. If you go to compute engine, TPUs, these are the machines that I have right now, but you can create new ones. So I have in this markdown file, this is the first command here for setting up a machine named Node 1 using the zone US Central 1F and the type of accelerator, the type of the TPU, and this is the software. This is the general software. They have software versions specific for PyTorch, for JAX, but this is the general software using Ubuntu. This command here will create this machine, this one, as per the requirements of the research support. And there are the following three commands will create these three machines. As you can notice, there is only one on-demand machine here. In the command for this one, I didn't use the flag preemptible. And in all the following machines, I use the command. So you just need to copy the command here, go to the Google Cloud interface, open the terminal, then you just paste it. But I'm not going to run this command because I already have the machine up and running. So I'll just delete this command. One more thing, if you cannot, sometimes due to high demand on the TPU machines, you cannot create a virtual machine instantly. So you have to use something called queued resources. In queued resources, you are creating a queued resource. Here I'm creating queued resource number 1. And basically you are asking for a node to be called node number 2 with these specifications. On this program project, on this zone, using this accelerator and this software version. What happens in queued resources that once you place this command, you will wait for you will be queued in a queue maintained by Google. Once there is a virtual machine that meets your requirements, they will assign it for you. Actually, I created this machine here using queued resources. So I just ran the command and within, I think, 3 or 4 hours, yeah, I got the machine up and running. So this is the machine, node number 2, it's in this zone, and this is the software version, and this is the internal and external IPs. To log into this machine, you can run the SSH command from here, or you just simply click on SSH. This will open a new window with a terminal inside that virtual machine. Yeah, so this is the terminal in the virtual machine. This is my home directory. There's nothing, it's empty. So the first thing I'm going to do is installing JAX. I got all these instructions from the Google Cloud documentation. So this is the first one, using JAX. And this is the second one for PyTorch. To install JAX, just copy this command, go to the terminal, and paste it. Yeah, the VM label here. The markdown syntax, I have to remove these. Yeah, these got copied. So this will install JAX. JAX is a deep learning library by Google, and it's optimized to be used on a TPU or GPU. So JAX is installed. Let's check by running some Python code. Use this command to check the devices used by JAX. So it returns number 4. The number of TPU cores is displayed. If you are using a V4 TPU, this should be 4. If you are using a V2 or V3 TPU, this should be 8. So because we are using a V4 machine, JAX returned 4. Just to check another Python code. Yeah, so JAX is installed now. Let's exit the Python. And now let's run a project using flax. Flax is a deep learning library. It's on top of JAX. So you can think about JAX as an NumPy equivalent, but it can talk to TPUs and GPUs. And flax on top of JAX just for neural net layers. It creates the layers, the linear layers, the transformer layers. So flax runs on top of JAX. So we have to install flax. Some data command line. This will install TensorFlow. I think TensorFlow is installed by default. No, there is some dependency. Or because this is a general software version using Ubuntu, TensorFlow was not installed on this. Let's check if anything's changed in our directory. No, nothing's changed. So let's get flax. Let's install flax for the current user. Yeah, now we have one folder in our directory. It's called flax ls. Now these folders should be similar to flax GitHub repository. Let's verify that by going to flax on GitHub. So yeah, authors, change like license. Yeah, they're all here. So you copied flax GitHub repository in your home directory. Now, and flax was installed to the current user. Now let's run an mnist example from flax examples by going to examples mnist. So let's see the examples. Let's go to examples. Mnist. There is a Jupyter notebook and a training script. So in the documentation, they posted this command. It keeps the all the configuration to the default. It only changes the learning rate and the number of epochs to 5. So let's run this. Yeah, this is epoch 1, 2, epoch 3, 5. So the accuracy used to be 93, it's 99, so it's learning something. And the training loss was reduced. So it's similar to the output I had in the markdown file. So now we got JAX running and flax running on the TPU virtual machine. Let's have PyTorch on this virtual machine. So PyTorch, the original PyTorch, it's library. It runs on CPU or CUDA devices, that GPUs. But with the emergence of TPUs, PyTorch released a new library for TPUs. So if you go to GitHub, PyTorch XLA. So PyTorch XLA is a Python package that uses XLA deep learning compiler to connect PyTorch deep learning framework and cloud TPUs. You can try it right now for free. So this is an updated version of PyTorch that runs on the TPU. Let's install it using this command here. So this command will install PyTorch XLA, and Torch Vision. Get. I have to change this. I have to remove this from the markdown file. So now I think PyTorch was installed. Let's go back to our original directory. And let's set the device to TPU. Now in the documentation, they put this script, this PyTorch script, into a Python file, and they run that file using the Python command to check if PyTorch is running with the virtual machine or not. I copied this script and I put it into a Python file here. Now I have to upload this Python file to the virtual machine. So I have to make sure that I am on the original directory. Yes, I can use this option here, choose file. There should be a progress bar in the bottom right corner here, showing the progress of upload. Okay, so let's try it again. Yeah, so it's restarting. So I restarted the terminal session and I have to try to upload the file again. Now I have the Python file here. To run it, I have to use this command just to check PyTorch was installed correctly. So this is the first tensor, second tensor, and the sum. They're all on the same device, first XLA device. I'm not good at adding negative numbers, so let's look for two positive numbers. Yeah, here 0.53 and 0.69. Yeah, they were added to 1.22. Yeah, so now on this virtual machine, I have JAX installed and I run an nest example. And also in that same machine, I have PyTorch XLA installed and I run a small PyTorch script. One nice thing to have is if you can run JupyterLab on the virtual machine. There is an article about this in the documentation, connecting to a JupyterLab. It says something about connecting to the port 8080. But for some reason, I cannot get this running on the TPU virtual machine. I don't know what's going on, but I believe it's something related to the firewall rules. So if you go to the network, this is the default network. And these are the two TPU virtual machines that I have. I think there is something needs to be done here in the firewall to allow connecting to custom ports. So this is how to prepare a TPU virtual machine on Google Cloud using the research support from Google. But the problem is there aren't many research projects that are done on TPUs. Most of research projects are adapting GPUs. So you should look into this research support. If you're using JAX, definitely you should look into this because these virtual machines are optimized for JAX. And if you're teaching JAX or if you're doing research with JAX, yes, you should be looking into this. The same thing goes for TensorFlow. So JAX, TensorFlow, Yeah. You just look into these virtual machines, and you should be doing your research or your teaching using these virtual machines. But if you're using PyTorch, basically depends on the availability of hardware. Can you get a GPU? If you can't get a GPU, you should go with go for that, because there are some dependencies, some CUDA dependencies between research projects. Because let's be honest, if you're doing research, you are relying on the other researchers' projects, so you are tied with what they are using. If they are using GPUs, honestly, you don't have an option unless you use TPUs. But if you are looking into a research project that uses JAX or uses TensorFlow, this is a great option. That's it, guys, for today's video. You can find the markdown file with all the commands that you use to set up these virtual machines. You can find that file in the description below. Thanks for watching. Bye.